Hello friends, so now we shall see some problems related to application of Bernoulli's principle. All these questions I have uploaded in our Google Classroom with the same question number. So you can refer the Google Classroom to see these questions, and the explanations will be uploaded as video lectures in our YouTube channel. So let us see question number 40. Water is flowing through a pipe having diameter 20 cm and 10 cm at sections 1 and 2 respectively. The rate of flow through the pipe is 35 liters per second. Section 1 is 6 meters above datum and section 2 is 4 meters above datum. If pressure at section 1 is 39 Newton per centimeter square, find the intensity at section 2. This is a straightforward question. We have been asked to find out the intensity of pressure at section 2. Intensity of pressure at section 1 is given, and they have also said that the pipe is carrying water and it is having two different diameters at two different sections. At section 1 the diameter is 20 centimeter, and at section 2 the diameter is 10 centimeter. So the pipe is a tapering one. At section 1 the diameter is higher compared to section 2. From that we can understand that the pipe is tapering. The rate of flow is given as 35 liters per second. And the section 1 is 6 meters above datum and section 2 is 4 meters above datum. So it's an inclined pipe also. If the pipe was horizontal, the section 1 and section 2 would have been at same height. So we can infer that the pipe is a tapering pipe and it is inclined. So let us draw the figure. So while solving the problems related to Bernoulli's principle, the first and foremost thing that you have to do is draw the figure correctly. Then only you will be able to solve the problem effectively. So if you draw the figure correctly, you will get the idea about the arrangement and the idea about how to proceed in solving the problem. So let us draw the figure. First and foremost, we have to draw the datum. So I'm drawing the datum. Now, they have told that the pipe is having two sections, section 1 and section 2. Let us draw the central line. I've drawn the central line like this because the pipe is having two different Z values. Section 1 is at 6 meter from datum, 6 meter, and section 2 is 4 meter from the datum. So I'm going to mark that also. 6 meter and 4 meter. Now at section 1 the diameter is 20 meters, and at section 1 the diameter is 10 meters. So this will be the arrangement. Section 1, section 1, section 2. Let us write all the given data. Section 1, section 2. Section 1, diameter equal to 0.2 meters, and section 2, diameter equal to 0.1 meter. So remember to express everything in meters because we are using G, and G, the value of G is 9.81 meter per second. So if you use the values in centimeter, you will have to convert G into centimeters also. It's better you keep everything in meters. D1, D2. Now we need to find out the pressure at section 2. We have P1 as 39 Newton per centimeter square, which is equal to 39, which is equal to 39 into 10 power 4 Newton per mm meter square. That's a conversion. Now Z1 will be equal to 6 meters. V1 we will have to find out from the equation Q equal to area into velocity, discharge equal to area into velocity. From that we can find out V1, and similarly V2 also. V2 also we can find like that. Now let us find out V1. Let us find out V1. Let's find out V1 is equal to Q divided by A1. Q is 35 liters per second. That happens to be 0.35 meter cube. 0.35. No, 0.035. 0.035 meter cube per second divided by pi d square by 4. This will be V1. You have to convert liters per second into meter cube per second because we are doing everything in SI units. Therefore, V1 will be equal to V1 will be equal to 1.114 meters per second. Let us find out V2. V2 will be equal to Q divided by A2 because as we all know, whatever quantity of water present over here will reach this point also. So the Q will be same. Q will be same. The water quantity of water is present at section 1 will reach section 2. So the discharge will be same. So Q equal to Q, that is 0.035 meter cube per second divided by pi into 0.1 square by 4. That will be 4 times of this one, 4.456 meter per second. That will be V1 and V2. Therefore, we got V1 as 1.114 meters per second. P1, V1, Z1 is known. Let us write P2, V2 and Z2. P2 we need to find out because in the question they have said that if pressure at section 1 is 39 Newton per centimeter square, find the intensity at section 2. We need to find out P2. Z2 happens to be 4 meters and V2 happens to be 4.456 meters per second. So we have P1, V1, Z1. We have Z2, V2. We need to find out P2. So the obvious way is to apply Bernoulli's principle at section 1 and 2. At section 1 and 2. So let us write that applying Bernoulli's principle at 1 and 2, we can write P1 by rho g plus V1 square by 2g plus Z1 will be equal to P2 by rho g plus V2 square by 2g plus Z2. And solving, we will get P2 is equal to 40.27 Newton per centimeter square. It's a fairly straightforward question. I hope it is clear to you. So the first objective is to draw the figure, write the given data, and then move to solving the unknown.